All right, this is the last part of lesson 9, which was about the location in a distribution, but now we're going to focus on transforming the data. So what could happen when we change all of our data by a constant? So what we're talking about in this video is how does our values change when all of the data gets changed by a constant. Now there's 4 ways that we could change data by a constant. We could add a constant to all values. So if we add a constant c to every single value, so maybe we give everybody a 5-point bonus on a test. We could subtract a constant from all values. So we could subtract a constant. So maybe we take every single person's score and we deduct 5 points. We could multiply all data values by a constant. So maybe we want every value to be a double grade, right? Maybe you want your test score to be a double grade. So we're going to take everybody's value and multiply it by 2. And lastly, we could divide all data values by a constant. So maybe we're going to take all of our values and we're going to divide them by 2. We're going to cut everybody's value in half. Now, just be aware that multiplying and dividing, remember, kind of are the same thing, because you could divide is the same thing as multiplying by the reciprocal. So any division problem could be changed into a multiplication problem. Keep that in mind. All right, so regardless of what we do, we must consider how the center, spread, and shape of our data will be affected, right? Because that's all you have to talk about: shape, center, and spread. So we want to make sure we understand how those things are affected by these 4 different transformations. So why transform data? Why would we even want to do this? Well, I did give you a couple examples, but let's go through some more. Maybe we are going to give a bonus, so 5 points is added to everybody's score. So again, that would be adding a constant, adding 5 to everybody's score. Maybe we want to convert from pounds to kilograms, right? So maybe we have everybody's weight in pounds, but we want to convert it to a different unit of kilograms. If you know anything about converting pounds to kilograms, you have to multiply the pounds by 2.2 to convert it to kilograms. That is an example when we would need to multiply. It could be a sale where all prices are slashed by 25%. So how do you convert with a percentage? Well, hopefully this is going to make sense to you. That you guys are in an AP stats class here, so this should make sense. But if all prices are slashed by 25%, that means that you would take the old price and you would multiply it by 75%, right? Because it's now worth 75% if it's being cut down by 25%. So hopefully that makes sense to you. So again, I'm multiplying the price of my whatever shirt or pants by 75% to get the new price, since it's being reduced by 25%. We made a mistake and 3 seconds need to be taken away from everybody's time. Maybe we were judging people's, times to run a 400-meter dash or something, and we made a mistake and we got to subtract 3 seconds from everybody's time. That would be subtraction of 3 from everybody's time. And maybe we're converting from the amount of sweatshirts to the price of sweatshirts, right? So for example, maybe we sold 1 sweatshirt, and then we sold 3 sweatshirts. Another day we sold 5 sweatshirts, and another day we sold 7 sweatshirts, and we want to convert the number of sweatshirts to money because every sweatshirt is worth $10, right? So I'd have to multiply every value by 10, which would convert them all to dollars now. So that 1 sweatshirt would be worth $10, 3 sweatshirts, $30. You get the point. So there are several situations where it would make a lot of sense to convert or transform our data. All right, let's talk about addition and subtraction of a constant first. When a constant is added or subtracted, your data will all shift up or down by that constant. Sorry for that typo there with all. So again, if you add the same value to all of your data, right? So imagine my data. So here's my lowest point, the min, and the data goes all the way up here to my max. And if I'm just going to add 5 to everybody, well, the entire set of data is going to shift up 5, right? Because that's what happens when you add 5 to every value. Or the same thing is I could subtract 5 and the whole data set is going to shift down. So what does change? So the mean and this median, the center, right? Mean and median are 2 ways that we describe center. Those 2 things are going to increase or decrease by the constant. So the mean would would be increased by 5. The median would be increased by 5 if you're adding 5 to all of your data. However, the spread, which we measure with standard deviation, IQR, and range, will not change at all. Think about that. Look at my example down here. I have my data, and if I add 5 to every value, it's just going to shift up. But the spread of the data, the max to the min, is not going to change. How far values are from the mean are not going to change because they all shift up the same. So spread does not get affected at all by adding or subtracting a constant. And what about the shape? Well, the shape's not going to change. If you're skewed right and everybody just moves over a little bit, you're still skewed right. If you're nice and perfectly symmetric and everybody just shifts down, you're still nice and symmetric. So that is how the addition and subtraction of a constant affect your data. All right, what about multiplying or dividing? When all data values are multiplied or divided by a constant, the data expands or contracts by that value. So the mean and median will get multiplied or divided by that value, right? If all of your values are going to double, well, obviously the mean is going to double and the median is going to double. If all of your values are going to be multiplied by 75% or 0.75 because you are reducing your costs, then the mean is going to get multiplied by 0.75 and so is the median. But when you are expanding or contracting your data, you are affecting the spread of it. It's definitely, again, expanding or contracting. So the spread, standard deviation, IQR, and range, they will also get multiplied by that value. So all you kind of have to think about here is multiplication or division affects everybody. Everybody, mean, median, standard deviation, IQR, range, they all get affected by multiplication or division. Now, the shape will shift around, but the general description of the shape will not change. So let me kind of give you a really simple example here. If I am skewed to the left, right, so my data is mostly here on the right and it trickles down to the left, and what I do is I multiply everybody's score. What that's going to happen here is I'm going to kind of expand and maybe look like that. Everybody's score multiplied, so my data spread out a little bit. But it's still skewed left. So the shape is not going to change because of multiplication division. So the shape is kind of something that always stays basically the same. It's the other values, the center and the spread, that you really have to think about. All right, let's just do a generic problem. Problems like this are very, very, very common on the AP test. So data will be converted from the original value x to the new value y by using the following equation. So we're going to take our data, our old data, we're going to multiply it by 2.5, and then we're going to add 10. Right, order of operations is multiply first, then add. Even though I have the 10 first, you guys should know order of operations. Okay, so that's how we're going to convert our data. So if our mean under the old data, our mean is 8, median is 12, IQR is 9, standard deviation is 4, max is 25, I want to figure out what is the new value going to be after this conversion. Well, mean, remember, gets affected by addition and multiplication. Mean gets affected by everything. So the mean is going to be 2.5 times 8 plus 10. So the new mean would become 30 because mean does get affected by both multiplication and addition. So 2.5 times 8 plus 10 is 30. Same thing with the median. Median is another measure of center. It gets affected by addition and multiplication. So 2.5 times 12 plus 10 gives me a new median of 40. Okay, now moving on to IQR and standard deviation. Remember, these are measures of spread. And spread only gets affected by multiplication. So the addition of the 10 does not affect this stuff at all. So I would only do 2.5 times 9 and 2.5 times 4. I would not add 10 because the addition is not going to affect measures of spread. So 9 times 2.5 would give me a new IQR of 22.5. And 2.5 times 4 would give me a new standard deviation of 10. So remember, multiplication only affects IQR and standard deviation. Well, I take that back. I said that kind of wrong. Multiplication affects everybody, whereas the addition of the 10 only affected the mean and the median. So be careful with that. Now the max is just a value, right? The max is one value. Any single value is going to get affected by everything. So 2.5 times 25 plus 10 would give me a new max of 72.5. So any particular value on itself, like even Q1, Q3, those are just individual values. They're going to get affected by both multiplication and addition. But it's the measures of spread that only get affected by multiplication or division. So keep that in mind. All right, one more example I want to do with you here, just because I've seen this on some AP tests before. Now, let's use the same formula before. So we're going to take our old score, multiply by 2.5, and add 10 to get our new score. And we want to know, how is the variance affected? Now, remember from our discussion about standard deviation, right? Standard deviation is found by finding your variance and square rooting it, right? So variance is just a step along the way to find standard deviation. Right? So variance, remember, is the average of your square deviations, but then you got to square it to get the standard deviation. So standard deviation and variance are very linked. So variance is a form of spread as well. So the addition of 10 is not going to affect variance in any way. But the problem is we need to work with standard deviation here. So we also have to know that standard deviation squared is equal to variance. And if you guys know anything about squares and square roots canceling each other out, this should make complete sense to you. So the variance of the original set of data is 9. So the old set of data had a variance of 9. Now typically for variance we just say it's s squared because look right here, right? Standard deviation squared is variance. So the first thing I have to do to find the new variance is I do have to convert that to standard deviation. So if the variance is 9, how do I get standard deviation? Well, the square root of variance, right? So the square root of 9 would give me a standard deviation of 3. So my standard deviation for this particular problem would be 3. Makes a lot of sense. The square root of variance is standard deviation. Now, let's convert that. So if the standard deviation is 3, remember the 10 will not affect that. The standard deviation is only get affected by the 2.5. So I would take 2.5 times 3, and I get 7.5. So 7.5 is my new standard deviation. Now, how do I convert that new standard deviation to the new variance? Well, I got to remember that variance would be standard deviation squared. So standard deviation squared would be equal to variance. So I would take 7.5 and square it to get the new variance. So the new variance would be 56.25. That'd be the new variance. So a little bit tricky there, a little bit to remember, but just keep in mind that variance and standard deviation are very closely linked. You need variance to find standard deviation. So it is a measure of spread, so you do not need the addition of 10. Remember, addition does not affect measures of spread. And to do this problem, you just have to think about converting. Let's take the variance of 9 and let's just make it a standard deviation, right? And you can make any variance a standard deviation just by square rooting it. So I do get a standard deviation of 3. And then, of course, I can convert the 3 by using my new system of converting my data, which is multiplying by 2.5. And then now that I have the new standard deviation, I do have to square it to get the total variance. So hopefully that made sense. I do see that pop up on the AP test every now and then, so I wanted to make sure I showed you an example of that type of problem.